All right, so we are going to solve let's see, what should we solve? I think we're going to solve number 7 because it's going to leave you with the weird fractional form, which we haven't seen before. So let's get rid of all this other junk for now. Whoop. Let's get rid of all that junk and solve number 7. Okay. And number 7 is an interesting one because it has this weird form, x and then in parentheses. But that should not confuse you. Don't let them bamboozle you with these weird forms. We just expand at this term. And so x squared plus 7x is equal to 8. Now, if we wanted to factorize this expression, we would want to move the number 8 over to that side of the equation and then find the factors. But because what we're trying to do here is complete the square of this expression here, x squared plus 7x, we don't need 8 on this side of the equation. We don't need to move 8 over, okay? So 8 can stay over on that side. And so what we're going to do is we're just going to move 8 a little bit to the right to make room for a new value we're going to put in here to complete the square. Okay, and how do we come about this value? Well, we just take this coefficient here, plus 7, we divide it by 2, and then we square all of that. I have this weird cucumber-shaped parentheses. We square all of that. Okay, and what should that give us? That should give us 7, that should give us 7 over 2 all squared should give us 49 over 4, right? Because the square applies to both the numerator and the denominator. Okay, and therefore 49 over 4 becomes the number that we add in here, plus 49 over 4. Okay, and of course in mathematics, if you add something to one side of the equation, we also need to add it to the other side of the equation so it stays balanced. So we add it over here, plus 49 over 4. Okay, and we can erase this weird thing that I've put there. Okay, and now what can we do? Well, it turns out that that little algorithm we just applied to the left side of the equation made it a perfect square. So this is now a PS, a perfect square. And its roots are x and this number here, plus 7, divided by 2. So x plus 7 over 2 all squared should expand out to that thing up there. And if you don't believe me, let's go over the identity, which by now I expect you to know that a, why are you giving me a black color? I asked for green. A plus b all squared is equal to a squared plus 2ab plus b squared. Okay? And so if a is really x, or x is really a in this analogy, then the same way that a became a squared, x becomes x squared. You see that? Okay? And if b is really 7 over 2, these two things are equivalent, b and 7 over 2, then the same way that b became b squared, 7 over 2 became 49 over 4, okay, which is 7 over 2 squared, okay? And this middle term is also equivalent, plus 2ab. How is it equivalent to that? Well, if 7x, let's see, if 7x, we're saying, is equivalent, let's make up some notation here for equivalency. 7x is equivalent to 2ab, well, let's put this 7x in the same color so you don't get too confused. If 7x is equivalent to 2ab, then, right, and we had also established that this x is equivalent to the a, so we can cross out the a from both sides, okay? So we can get rid of this a from both sides. And so now I'm saying that 7 is equivalent to 2b. So if we divide both sides by b, okay, that helps us establish that the number 2 is equivalent to 7 over b. Wait, sorry, what am I doing? if we divide both sides by 2, not by b, divide both sides by 2, that helps us establish that b is equivalent, all right, b is now equivalent, as you can see, to 7 over 2. All right, so b is equivalent to 7 over 2. Okay, I hope that clarifies things. Again, this can be a bit dicey, a bit convoluted, but I hope it clarifies things just a little bit. All right, well, let's put this all aside. Let's put that all aside. How do we do that? Let's get it out of our main screen. Go away. Go away. I don't want you here. Get smaller. Get smaller. Okay, just so you have it there for reference. Let's get back now to our main equation. So we have x squared plus 7x plus 49 over 4 is equal to 8 plus 49 over 4. And we said that this thing here becomes x plus 7 over 2 all squared is equal to 8 plus 49 over 4. Now, how do we proceed? Well, we could try taking the square root of both sides, but let's see, would that help us? That might not be the best idea. So what we might do instead is we might add these two together. So if we add these two together, assuming that 8 is really the fraction 8 over 1, okay, 8 is really the fraction 8 over 1. Well, let me clarify something very quickly, Ari. Why don't we just take the square root of this whole thing, okay? Because you might be tempted to say the square root of 8 plus 49 over 4 is the same thing as the square root of 8 plus the square root of 49 over 4. But that does not hold. That is not true, okay? That is not true. So this would evaluate to, let's see, this would evaluate to, what's the square root of 8? That would be something at about 2 point something, let's say, 2.8-ish, 2.9-ish, plus, and I guess here you would get, what fraction would you get? You would get some wonky fraction, 7 over 2, okay, no, not that wonky, 3.5, okay? And this is not correct. Think about, let's make it simple. Let's think about if we had the square root of let's see, of 4 plus 4. No, that would be a bad example because that would actually work. The square root of 9 plus 9. You might be tempted to say this is the same thing as square root of 9 plus square root of 9, which gives us 3 plus 3, which gives us 6. But notice, if you take the square root of these two things added together, square root of 18, 6 times 6, does that give you 18? Is the square root of 18 6? Of course it's not, okay? So that doesn't work, okay? Sorry for that long digression, but I saw it was going to be tempting to you, so let's continue. All right, so we add these up. All right. 1 into 4 is 4, and then 4 times 8 is 32. 4 into 4 is 1, and then 1 times 49 is 49. And we add these two together, and that should give us, let's see, what is 30 plus 40? That's 70. And then we have an extra 2 plus 9, which is 11. So 70 plus 11 should give us 81 divided by 4. Okay, and so now we can continue writing out our equation as x plus 7 over 2 all squared is equal to 81 over 4. And now we can take the square root of both sides. Now it's safe to take the square root of both sides because this square root just cancels out that squared. Okay, so those leave. And this square root applies to both the numerator and the denominator. So this thing then becomes equal to square root of 81 over square root of 4, which is equal to 9 over 2. Okay, and so now we write out on the next line that x plus 7 over 2 is equal to plus or minus 9 over 2. Sorry, I forgot that here. Okay, you agree that this could be plus or minus 9. All right, plus negative 9 times negative 9 gives us positive 81. Okay, and so now we have x is equal to either plus 9 over 2 minus 7 over 2, right? Subtracting 7 over 2 from both sides, which should give us 9 minus 7 is 2 over 2, should give us 1. Or the other option is it's equal to minus 9 over 2 minus 7 over 2 is equal to minus 9 minus 7 is minus 16 over 2, sorry, which is equal to minus 8. My stomach just loves making weird noises when I'm making videos. Okay, and if you like, you can go ahead and plug these two roots that we've just found, these two values of x, into that expression, just to make sure you didn't make any mistakes or you haven't invented something. I won't do that because I'm tired and I think this is correct. Okay.